Hello, welcome to another video of Math and Science Guide. Today we are going to discuss how to express decimal numbers to rational numbers or fractions. Okay, today we can see how to express both repeating decimals and non-repeating decimals to rational numbers. Okay, as you can see, what is a 0.333 etc. Can you express it in the form of rational numbers? Yes, it is just 1 by 3. Like that, what is 3.142142142 etc. Can you express it in the form of a numerator by denominator? Yes. So, in this video, you will see how to express repeating decimals to rational numbers. Okay, if you are new to this channel, please do subscribe to our channel, and if you find this video useful, please like, share and comment below. Okay, we can start the video. So what are rational numbers? Rational numbers are any numbers that can be written in the form p over q. Okay, where p and q are integers. What are integers? Integers are numbers 0, 1, 2, etc. And also it's negative. Negative 1, negative 2, negative 3, etc. This is set of integers. Okay, is 0.2 an integer? No. Just 1, 2 counting numbers, 0 and it's negative. That are integers. Here rational numbers are an integer over an integer, another integer. Okay, and another peculiarity is this denominator cannot be 0. Q is different from 0. Q is not equal to 0. Okay, so any number that can be expressed p over q form, where p and q are integers and q is different from 0, are called rational numbers. Okay, can you say some examples to rational numbers? Yes, 1 by 2 is a rational number. Negative 3 over 4 is a rational number. 1 over 1000 is a rational number. All these are rational numbers. Okay, I'll ask you some questions. Is 0 a rational number? Can we write 0 in the form p over q, an integer by integer? Yes, of course. 0 is 0 over 1 is 0. Or 0 over 4 is 0. Or 0 over any number is 0. Or we can write a 0 by 1000. Everything is here a 0. Is 1 a rational number? How can we write a numerator by denominator form? 1 is, we can write 1 over 1 is 1. Or 2 over 2, it is also 1. Or 3 over 3, it is also 1. Or 100 over 100, it is also 1. That is, any number divided by that number gives 1. So 1 is also a rational number. Like that, we can write any integers in the form p over q. So all integers, every integers are rational numbers. How will you write 3? We can write 3 over 1 or 6 over 2. All these are 3. How will you write 100? 100 is 100 over 1 or 200 over 2. Okay, so every integers can be expressed in the form p over q, an integer over another integer. So all integers are rational number. So other than these integers, what all numbers comes under rational numbers? See, 0.5. Is this a rational number? Yes, 0.5 is 1 over 2, 1 by 2. This is just a half. Okay, 0.25. 0.25 is 1 over 4. And 0.333 etc. Is this a rational number? Yes, this is also a rational number. This is a 1 over 3. So we can see how to write this decimal numbers to rational number form. Okay, a numerator by a denominator form. Okay, we can see. So we can see 0.5. 0 0.5. How will you write in the numerator by denominator form or a fractional number form? When we multiply a decimal by 10, its decimal point move to the right. Okay, so zero point 0.5 into 10 is equal to, this decimal point will move to the right. That is, it is 5. Okay, or we can write 5.0 or just simply 5. If I multiply this by 100, what will happen? Zero point 0.5 times 100. Decimal point will move 2 places to the right. That is, it will become here 0 0.5. Decimal will move 1 place. It will become 5 point. Again 50 point. Okay, this is 50.0 or just 50. If I multiply 0.315 by 10, 0.35 times 10, what will happen? The decimal point will move to the right 1 place. Okay, that is 3.15. If I again multiply by 10 or just multiply 0.315 with 100, what will happen? 0.315 times 100 is equal to, decimal point will move 2 places to the right. That is 31.5. If I multiply this by 1000, 0.315 times 1000, see how many zeros are there in 1000? 3 zeros. So decimal point will move 3 places to the right. That is 315. Okay. So to write in the numerator by denominator form, here we can just cancel this decimal point by multiplying by 10. Okay. Here after the decimal point only one digit, so it's enough to multiply by 10. Okay, zero point 0.5 times 10, then divide by 10. If I multiply a number by 10, it will change, that number will change. See, this is 0 0.5 itself. 0 0.5 times 10 by 10. 10 over 10 is 1. So 0 0.5 multiplied by 1. Any number multiplied by 1 is that number itself. That's why we are multiplying by 10 and also dividing by 10. So 0 0.5 times 10 is 5. 5 over 10. Okay, 0 0.5 times 10 is 5. 5 over 10. What is 5 over 10 here? 5 is a common factor of this. So 5 divided by 5 is 1. 10 divided by 5 is 2. 1 over 2. So 0 0.5 is 1 over 2. So what is 0.315? To cancel this a decimal point, here after this decimal 3 numbers. Okay, after this decimal there are 3 numbers. So we can multiply by 1000. So 0.315 into 1000 is 315 divided by 1000. This is 0.315. Okay. So we can easily change any terminating decimals to fractions. I will show you some more examples. What is 3.142? How to express it in the form of a numerator by denominator? Here after the decimal there are 3 digits. So just multiply by 1000 and divide by 1000. That is 3142 divided by 1000. That is 31.2. Here after the decimal only one digit. So multiply by 10, divide by 10. Multiplied by 10, the decimal will cancel. That is 312 by 10. What is 25.65? Here after the decimal, 2 digits. So 2565 divided by 100. 2 digits. So 100 has 2 zeros. Like that, you can change any terminating decimals to fractions. Next, we can see how to change non-terminating decimals to fractions. So, for a simple example, take 0.3333, etc. Okay, this is a non-terminating decimal. How can we express this an integer over another integer form? Here see, 0.333. When when we multiply it by 10, what will happen? We can call this x. Okay. Then multiply it by 10. That is 10x is equal to, decimal goes to one place to the right. That is 3.3333, etc. Okay. Then if I subtract x from 10x, what will happen? 10x minus x is 9x. 3.333 minus 0.333, etc. That is 3.333, etc. minus 0.333, etc. Okay. All the digits after the decimal will cancel. 3 minus 3 is 0. 3 minus 3 is 0. And 3 minus 0 is 3. This is just 3. That is here 9x is equal to 3. 10x minus x is 9x is equal to 3. So what is x here? 3 over 9. What is 3 over 9 here? 3 and 9 has common factor 3. So 1 by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So it is 1 over 3. That is x, or 0.333 is 1 over 3. Okay, we can see another number. How to express 3.4121212, etc. as a ratio of two integers, or as a fractional number, numerator by denominator, an integer over another integer form. How can you express this? See, we can take this as x. If I multiply this by 10, what will happen? 10x is equal to, this decimal move to one place to the right, that is 34.1212, etc. Okay, so just see, if I subtract x from 10x, what will happen here? Some digits will remain in the decimal. After the decimal, some digits will remain. So we can just multiply it again by 10, or just x by 100. That is 100x is equal to, again multiply by 10. That is 100x is equal to, again decimal point will move one place to the right. That is 341.212, etc. See here, again if I subtract it, here after the decimal 2, here after the decimal 1, some digits will remain in the after the decimal. So again multiply by 10. That is 1000x, okay, is equal to 3412.1212, etc. See here 1000x and 10x. Here after the decimal 1212, etc. Here also 1212, etc. So 1000x minus 10x is 990x. 1000 minus 10 is 990. X is equal to, here 3412.1212 minus 34.1212, etc. We can see 3412.1212, etc. minus 34.1212, etc. Here after the decimal, all the digits cancel. 2 minus 2, 0. 1 minus 1, 0. 2 minus 2 again 0. So after the point, 0. Here 2 minus 4, or 12 minus 4, 8. Here 10 minus 3, 7. Here 3. 3 minus 0, 3. So this is 3378. So what is x? 3378 over 990. So write it in the simplest form. It will be 563 by 165. Whenever writing a fraction or a rational number, just try to write it in the simplest form. Okay. So we can see one more example and we can stop the video. Okay. Next example is 1.25333, etc. Express it in the form of ratio of two integers. Okay, we can call this as x. Then what is a 10x? 10x is 12.533, etc. Okay, here after the decimal 5, here after the decimal 2. No use. Again 100x. 100x is 125.33, etc. Here after the decimal 3, here after the decimal 5, no use. Again, 1000x is equal to 1253.333, etc. Here after the decimal 3, here after the decimal 3. So subtract this. That is 1000x minus 100x. That is 900x is equal to 1253 minus 125. Here after the decimal, all the digits will cancel. 13 minus 5 is 8. 4 minus 2 is 2. 2 minus 1, 1. 1 minus 0, 1. That is 1128. So x is 1128 divided by 900. And in its simplest form, 94 by 75. So hope you guys understand this video. I will give some more examples to try by yourself. Express 5.444 etc. in numerator by denominator form, an integer over another integer form. How will you do this? Just to multiply by 10. Then after the decimal it will be, here it will become 54.444. Here this is x, this is a 10x. So 10x minus x is enough. 10x minus x is, that is 9x is equal to 54 minus 5. What is 54 minus 5? 49. Okay, so x is 49 by 9. Like that, write 0.852. Again, repeating this 852, 852, 852, etc. and numerator by denominator form. Try by yourself. Okay, hope you guys enjoyed this video. You understand this video. If you understand this video, if you find this video useful, please do share to your friends and please do subscribe to our channel. Thank you all.